Hi, Julian here. PROBAD is the software solution for internal pressure design of vessels and piping components. In this video I give an introduction to the modernized user interface by showing you how to do a simple internal pressure analysis according to EN 13480. This is the welcome screen divided into 3 columns. The navigation drawer on the left, in the middle an overview of recently used projects, currently still empty as this will be the first project, and on the right are templates. To create a new project, the new project template or the menu item on the side can be used. The menu bar contains basic subject areas and controls the displayed command bar below it. In this, the concrete commands can then be executed by clicking on the corresponding buttons. Generally, the structure of a PROBAD calculation is hierarchical. The top level is the order, which can contain various drawings. Several datasets or file entries can belong to a drawing and can contain themselves components. A dataset is a simple geometric element, such as a cylinder, an elbow or a dished head, which in turn can be extended by a component, for example a branch. This hierarchy is visualized by a tree structure on the left side. Individual elements can be selected and their properties edited in the input mask to the right. I would now like to present the principal procedure for working with PROBAD on the basis of a simple internal pressure design. First, I enable the help and activate that it automatically navigates to the corresponding place in the help document according to the context. At the beginning of a new order, a name and an order number are assigned. The component shall be designed according to EN 13480. Mandatory fields are indicated by a red frame. To assign operating data, the plus button can be clicked. An internal pressure of 16 bar and an external pressure of 1 bar are specified. A cylinder is specified as a new dataset. After entering the name and the position number, the material is to be set, but the drop-down menu is empty. The Material Management dialog window offers extensive filter options by name, material number, standard or type. With a click on Add, the selected material is added to the current order and can now be used. To be able to enter the dimensions, you can either click on Next in the command bar or select the element from the tree structure. After selecting the standard, the corresponding datasets are available in the drop-down menus for the dimensions. In this case, the wall thickness is to be determined and not specified. The length is specified as 6000 mm. Now the nozzles can be defined. The component branch is added to the dataset. The output nozzle N1 is defined first. It should be noted that this should be designed with a reinforcing pad. As soon as the corresponding entry has been selected from the drop-down menu, an additional item appears in the tree structure below the nozzle definition. Both the diameter and the thickness of the nozzles are specified. The outer projection is set to 150 mm. The material to be used is P235GH, the same material already used for the shell. Now the reinforcing pad must be dimensioned, 30 mm wide and 4.5 mm thick. A second nozzle N2 is to be created, but this does not seem to be possible without further ado. This is because the reinforcement pad is currently selected in the hierarchy. Only after an element is selected in the tree structure which allows the nozzle, the function is active again. The definition of the dimension parameters is very similar to the first nozzle. In this case, however, the thickness is to be dimensioned and not defined. The last step is to determine the position of the nozzle. This can be defined relatively or absolutely. With a double click or via the command by entry add, a positioning is assigned to a nozzle. By selecting Model Positioning in the tree structure, the command menu was automatically adapted. With respect to the origin, distance and circumferential angle are specified in this case. The model is now ready for calculation. The entire drawing or individual components can be calculated. In this case, the calculation of the entire drawing is the way to go. The results can be found on the dataset hierarchy level under the tab Results. Utilizations due to internal pressure and external pressure are shown. In addition, the PROBAD Classic report is displayed. The tab Documentation shows the complete report. The first page gives an overview of the calculation results and shows the most important parameters. Details of individual components can be found on the following pages. Alternatively, a short report can be displayed. The calculation report can also be exported as PDF. And that's been it. Thanks for watching, and I will see you in the next one.